let's look at some applications of vectors. Let's say we want to prove the angle in the semicircle is a right angle. That means this angle is 90 degree. So let's say this is A, this is B, and this is, let's say, a point P. Let's say we have a line to the center O. Let's say this is vector R. This is A in this direction. So in this direction it is also radius, so this would be minus A. AB is the diameter, O is the midpoint or the center of the circle, A is the position vector of B with respect to O. R is the position vector of P with respect to O. Now remember, OA is OB, R is OP, and OA would be equal to A itself. The only thing is direction is different, so this would be equal to minus A. Okay, so AP would be R minus A. AP would be R minus A. So which means R plus A. BP would be equal to R minus A. Remember, A equal to R equal to the radius of the semicircle. AP dot BP, the dot product, is equal to R plus A dot R minus A. Now remember, R and A are equal. But first let's apply the algebraic formula. Remember, A plus B, A minus B. So that is R minus A square, which is 0. Now that's the key. We know that if the dot product is 0, the dot product of two vectors, that means that the vectors are perpendicular to each other. So therefore, angle APB is equal to 90 degree, which is what we had to prove. Okay, let's look at another formula that we have to prove. A square is equal to B square plus C square minus 2BC cos A in a triangle ABC. This is also called as cosine rule. Okay, let's say we have this triangle A, B and C. Vector A, vector B, vector C. Now we know vector A plus vector B plus vector C, this is all in one direction. So if you start from B and start walking on vector A, then walk on vector B and walk on vector C, we know we'll reach back at P. So which means this is equal to 0. Okay, A equal to, we can say, minus B plus C. Now we want A square. So let's square this. A dot A is equal to, when we square the minus sign disappears, so we can ignore it. So B plus C dot B plus C, which is equal to B plus C square, and this would be magnitude of A square. So magnitude of A square is equal to B square plus C square plus 2BC cos, and this angle between the vectors. So if we move this to make it co-initial, then this angle would be the angle that we are interested in, and in that case this would be pi minus angle A. So cos pi minus a. So this becomes a square is equal to b square plus c square. Now cos pi minus a is minus a, cos a. So we can write this as 2 magnitude of vector b is b c cos a, which is what we had to prove. Now let's look at another one. Let's say we have to prove sin a by a sin b by b and sin c by c. So let's say this is the triangle in a triangle ABC. So A, B, C, and this is vector A, vector B, and vector C. In this direction, in this direction, in this direction. Now, if we start working on vector A, then vector B, and then vector C, we end up back at B. So if AB is equal to vector C, BC equal to vector A, and EA, CA is equal to B. Okay, now we know vector A plus vector B plus vector C is equal to 0. Okay, now this is the tricky part. We do a cross product with A on both the sides. So A cross product with the left hand side, cross product with 0 vector. Now A cross A is 0, so we don't have to write it. We are left with A cross B plus A cross C, and this becomes a 0 vector. Now A cross B is equal to minus A cross C. Now since it is not commutative, if we change the order, the negative sign goes off. So this becomes C cross A. A cross B equal to C cross A. Okay. Now similarly, we can prove that, or we can show that B cross C is equal to A cross B. So which implies A cross B equal to B cross C equal to C cross A. A cross B and A cross B are equal. So this is equal to this is equal to this. That means B cross C is equal to C cross A. Which means, if remember, these are cross products, so the result is vectors. So if the vectors are equal, that means their magnitudes are also equal. And we know how to evaluate the magnitude. AB sin pi minus C. Now pi minus C would be what? We have to extend this further. Then this would be pi minus C, because this is angle C. So this would be pi minus C. So AB sin pi minus C is equal to BC sin pi minus A is equal to CA sin pi minus B. Now sin pi minus theta is sine itself. So we can write it as AB sin C is equal to BC sin A is equal to CA sine B. Now divide by ABC. So AB sine C by ABC is equal to BC sine A by ABC, CA sine B by ABC, CA, C and B, AB. So we are left with sine C by C is equal to sine A by A equal to sine B by B. So that is just a few examples of application of vectors. If you want more, just have a look at analytical geometry. There is another playlist there. Every video, practically speaking, has the application of vectors. So that's it. Bye for now.